Take a seat, make yourself comfortable, because you're about to embark on a journey as far as possible, through time, towards eternity, until you witness the death of our universe itself. Because while no one can predict your future, it's different for the cosmos and everything in it. As strange as it may seem, the course of your life is infinitely more complex than celestial mechanics. At the beginning of the last century, most astronomers agreed that the universe is stationary and unchanging, that it has always existed and will exist for eternity. But in recent decades, this idea has been crushed like a hydraulic press. Because we discovered that the universe had a beginning and will have an end, thanks to the latest observations made on the largest scales of the cosmos, we are even able to tell its story. To dive into the apocalypse calendar of the distant future, we need to start with a little refresher. On the largest scales of the cosmos, everywhere we look, in all directions, we see that the universe is expanding. This expansion is evident in the fact that the farther away the galaxies we observe are, the faster they are moving away from us. Not because they are moving through space, but because the space between them is constantly stretching and expanding. A second strange discovery was added to this one. Because, by studying the light coming from the explosion of distant giant stars, we also discovered that this expansion is accelerating over time, as if the fabric of space were being stretched by a mysterious entity, a kind of repulsive force that we have called dark energy. And it is these two strange discoveries that allow us to outline the most probable scenario for the death of a universe that is accelerating in this cosmos, which is expanding ever more rapidly and does not contain enough matter for the force of gravity, which pulls objects together, to slow down or counterbalance this expansion. The expansion of space-time will never stop, and over very long periods, this will have terrible consequences. Because you will see that after an agonizingly prolonged death over time, a universe set on a path of eternal dilution ends up being slowly killed off by a kind of icy, internal, endless apocalypse where everything is plunged into darkness and silence. Atmosphere. So, rest assured, even if the volume of the universe we're in is doubling at a constant rate. The apocalypse timeline, according to the heat-death scenario of the universe, only begins long after our planet has disappeared. In about 5 billion years, when our star, having turned into a red giant and expanded to monstrous proportions, will engulf and incinerate our planet, dark energy will only start to show its effects. On a cosmic scale, the distances between galaxy clusters will not have even doubled from what they are today. The Sun King may have finished his reign, but in our galaxy, as in the entire universe, billions upon billions of other stars continue to shine, go out, or ignite. To truly see dark energy begin to take over, and the first signs of the cosmos's death begin, we need to move forward in time, until the universe is nearly 10 times older than it is today. Because in about 150 billion years, the deep sky will gradually empty of all light that has become too distant. All the galaxies located hundreds of millions of light years away from us will, one by one, fade into oblivion forever. And the part of the universe that can then be observed will be reduced to a size 2.5 times smaller than what we can see today. Thus, and in a completely counterintuitive way, as the entire universe gets bigger and bigger, we will be able to see less and less of it. For hypothetical civilizations existing in those distant futures, the deep sky will slowly close in, because all the distant galaxies moving away too quickly from their field of view will disappear. This process will unfold over hundreds of billions of years, during which the light coming from distant galaxies will continuously fade. moving increasingly toward the red, before slowly moving out of the visible range, then fading away completely, like old photographs erased by time. At the same time, dark energy, which keeps increasing the amount of available space, stretches the wavelengths of the light emitted during the Big Bang, and still travels the universe, to the point of making it fall below the background noise of natural emissions and erasing its trace forever. And while the trillions of galaxies contained in the observable universe keep visually disappearing, those that are close enough to each other for the gravitational force that binds them to resist the accelerated expansion will merge and turn into giant elliptical galaxies. Even if the deep sky has become completely empty, all the galaxies in the universe are still filled with billions of stars that bathe them in their light. Stars that, for the smallest and oldest ones, simply keep shining, just as they always have. And sometimes they have just ignited from collapsing clouds of gas. But this continuous abundance of new stars is just a flash in the pan on the scale of cosmic time, because their lifespan is limited, and above all, inexorably, the matter they feed on to shine or to ignite is being consumed and running out. And the great cosmic clock keeps ticking and the universe keeps accelerating. And in 450 billion years, throughout all the galaxies in the universe, it will be the turn of the brightness of the nearby sky to begin to fade. Because the clouds of gas from which stars are born are inexorably running out. Space is running out of its fuel, even though, when stars die, some of the matter that makes them up is often ejected into the surrounding space. It can then help form other celestial bodies. The vast majority remains trapped in their core, which means that in the long run, each sun is itself a small fuel prison. And in all the galaxies of the universe, there is therefore less and less matter available to create light. The twinkling of the firmament begins to fade away slowly. The stars disappear. This stellar twilight, with its increasingly pronounced darkness, will stretch over trillions of years. Because red dwarfs, the least massive stars, can shine 100 times longer than the current age of our universe. Yet, even though their lifespan is staggering, they remain insignificant in the face of eternity, one after another. Stars, even the most energy-efficient ones, go out, until the moment comes when, as the universe becomes nearly 1,000 times older than it is today, the very last one of them lights up. The era of stars formed from clouds of gas is over. The universe is then about 100 trillion years old, and we leave the stellar era to enter the degenerate era. Everywhere in the universe, galaxies plunged into darkness are now populated only by dying stars, stellar remnants such as white dwarfs or neutron stars. These bodies, although still hot on the surface, no longer undergo fusion and shine only very faintly, thanks to the heat they stored up as they were dying. And time, like a serial killer, keeps killing the seconds, the years. The trillions of years keep passing by, and space keeps expanding, until the surface temperature of these stars becomes so low that you could touch them without burning yourself. And when the cold becomes biting enough to bring their temperature below -168 degrees, all these stellar corpses turn into black dwarfs. The cosmos is then 1,000,000 trillion years old, and it is still young compared to the times to come. Strangely, in this universe without shadow and without light, it happens occasionally that the total darkness is briefly disturbed. Because in these pitch-black skies, all the stellar corpses are in motion. As unlikely as collisions between two dead bodies may be, time and the instability of their orbits work in their favor. Thus, on rare occasions, collisions between two dead stars can reignite their flames. So it is believed that each giant galaxy contains within it a small hundred temporarily active stars for every trillions of dark bodies. Even more rarely, it happens that binary systems of dead stars orbiting each other do not collapse. From these mergers, novas can be born, which, with their fleeting flash, dissipate for a few weeks the darkness of the degenerate air with a powerful burst of light and radiation, before everything falls back into darkness again until such an event happens once more. So, even though there is almost no light left, there is still movement. Because all galaxies in the universe become cemeteries of dust, rocks, and drifting, extremely cold celestial bodies. And when the universe becomes 10 times older than it was, at the moment when the very last star ignited from collapsing clouds of gas, in this silence of frozen ruined fields, chaos begins. As they keep crossing paths, the orbits of frozen planets, asteroids, and comets continue to revolve in the darkness around their extinguished star. Just like those of stellar remnants drifting around the center of gravity of each galaxy, they begin to wear out over time, and that's something there's no shortage of. As they keep crossing paths, all these orbital connections become more unstable and will eventually break apart. The lightest celestial bodies, such as frozen planets that escape the death of their stars, will be the first to suffer from these gravitational disturbances. Everywhere in the universe, the passage of compact celestial bodies nearby will eventually disturb them, to the point of sending them crashing into the dead star at the center of their system or tearing them away one by one. All planetary systems break apart and the great cosmic clock keeps ticking. And after trillions upon trillions of years spent brushing past each other, exchanging orbital energy, slowing down or speeding up, now it's the turn of the most massive drifting objects, the remnants of dead stars and black holes, to be ejected from their galaxy. Most of them, the lighter bodies, then wander off into the cosmos, while the heavier ones, whose orbits seem to grow tired, plunge toward the supermassive black hole that sits at the center of every galaxy in the universe. Fueled by the matter swirling rapidly around them, the edges of these black holes, these giant voids, are then temporarily transformed into quasars. These active galactic nuclei then become, for a time, the scene of gigantic outbursts of matter and radiation produced by the friction of debris. Disrupted stellar remnants, which are heated to billions of degrees before disappearing forever inside the black holes. And when the universe becomes 1,000,000 times older than it is now, when the last stars have gone out, all galactic structures have been completely stripped away. The brief return of light at the center of every galaxy in the universe is now permanently over. And the river of time continues to flow relentlessly in a universe that is still expanding at an accelerated rate, where nothing happens anymore, for a small eternity. To see something interesting happen again, we will have to move forward until the universe is 10 million trillion times older than it is today. From that moment on, matter itself will begin to lose its integrity and start to die. Because even if all light and almost all energy have long since exited, the atoms are still there, still in play, as cold and solid as they may be. Oxygen, carbon, iron, hydrogen, like all the other known stable elements, are still very much present. But the building blocks that make up matter are not necessarily eternal. And even if no one has ever seen an atom die, maybe the universe itself will. Protons in atomic nuclei are thought to be unstable over extremely long periods. If that's really the case, then, to make a long story short for you, when the cosmos reaches the age of 10 to the power of 34 years, all frozen celestial bodies, from the smallest speck of dust with no relation to wandering planets, including drifting black stars, will begin to evaporate. Because matter, having become unable to structure itself, then slowly disintegrates in a cascading process of decay, which emits a tiny amount of energy in the form of radiation. A frozen celestial body with our sun's mass emits as much energy as a running microwave. At the canonical age of 10 to the 43rd power years, the universe loses its last atom. And time itself keeps moving forward toward a new story, a story that begins with the era of black holes. Because these stars drift in the immensity of an ever-expanding space or sit at the center of each stripped galaxy. They are not eternal, and over time, even the most massive among them will eventually die. When the temperature of the universe, which keeps aging, expanding, and cooling, drops below that of black holes, they begin to evaporate through Hawking radiation near their surface. In the quantum vacuum, pairs of particles and antiparticles constantly appear and disappear. And now it's cold enough that near their event horizon, one of these particles falls into the hole while the other escapes. So every black hole in the universe starts to lose mass, and as the universe ages, each black hole gets thinner. The more massive it is at the start, the longer the process will take. But ultimately over very long periods, between 10 to the 40th power and 10 to the 150th power years, all black holes in the universe will vanish, emitting in the process, during the last milliseconds of their existence, large amounts of energy, as violent brief thermal flashes with few photons. So the only sources of light in the universe that briefly disturb the darkness of this theater, long without an audience, then originate from the darkest objects that exist today. And when the last black hole disappears, the universe enters its final phase. Unless the proton turns out to be stable, in which case, matter is still present when the last black hole finishes evaporating. And the drifting planets, freezing like the black stars, continue to persist in an ever-expanding volume of space, until the universe reaches the surreal age of 10 to the power of 65 years. From that moment on, all the things they still make up begin, through quantum tunneling, to arrange themselves in an exotic way, which gives matter a liquid-like behavior, and all bodies then become perfectly spherical. Then, over time spans from 10 to the 500th power to 10 to the 1500th power years, all the atoms that are still present will, through cold fusion, transform into iron, the most stable atomic element in the universe. Before the dust, planets, and iron stars reach that point, by quantum tunneling effect, they will transform into neutron mush, which will collapse into black holes that, in turn, will evaporate. In this scenario, as in the first, I've held on far longer than my weary imagination could have imagined. And when the universe reaches the inconceivable age of 10 to the power of 10 to the power of 66, all matter as we know it has completely disappeared. In the cosmos, only photons and neutrinos remain, devoid of energy and so diluted that they will never meet. There are then no more structures, no more contrast, and in this vast volume of space, nothing forms anymore, nothing happens anymore. From now on, only silence remains in the emptiness of sound. The universe is thermally dead, and its temperature is close to absolute zero. All forms of heat have dissolved in the expansion. We have entered the era of the Great Chill. And the universe is still an infant compared to the immensity of the times to come. Because before it lies an expanse of eternity, a very strange eternity, because the arrow of time is, in a way, gently murdered there by the disappearance of all cause and effect. Because even if the ever-accelerating universe technically continues to exist, it is nothing more than an ocean of almost pure emptiness, in which nothing happens anymore. That could be told. We've somehow reached the end of time. Only the expansion continues forever, if talking about duration still makes any sense, when any event has become impossible. Yet, there exists in this universe, now devoid of history, and whose conclusion stretches over an infinite number of black pages, a hidden exit that could allow this universe, in a state of eternal heat death, to escape from the absence of all possibility. If we consider that time continues to flow, then there will inevitably come a day when this universe will be 400,000, 1,000,000 times older than it is now, from the moment when nothing happens there anymore. But when you have eternity ahead of you, even the most dizzyingly improbable events inevitably end up happening. No matter how likely something is to happen, if the probability isn't zero, it will eventually occur. Because time isn't scarce. That might even be all that's left for the universe. And that's where things take an absolutely bewildering turn. Because statistical physics tells us that when you have an infinite amount of time ahead of you, so, by momentarily borrowing energy from the vacuum, quantum fluctuations of space can spontaneously bring particles into existence from nothingness, and thus fleetingly give rise to all possible configurations of matter that can be created. Of course, the frequency at which these objects appear is lower the more complex their arrangement is, and the greater the number of particles they contain. And the sudden appearance of a simple pair of particles is incomparably more frequent than the sudden materialization of a small rock, a rosebush, or an elephant. The manifestation itself is much more likely than the sudden appearance of a planet or an entire galaxy, but inevitably in an eternally expanding universe. It's always a matter of time, and everything that can possibly happen eventually emerges from nothingness sooner or later, including a brain called a Boltzmann brain, whose atomic configuration is exactly identical to yours, and which therefore contains all your memories, convinced that you have lived them. He imagines himself listening to this video before being disintegrated right after. And where it gets extremely weird is that all the things that can spontaneously appear by momentarily borrowing energy from the vacuum are doomed to return there almost instantly, right after. Since the energy borrowed to create them must be returned, all these manifestations are therefore fleeting, all except for one. Because among all that can be done, there is a new universe. In fact, there is a theory that tells us that after a practically infinite number of attempts, and while the clock of the thermally dead universe shows the surreal number of 10 to the power of 10 to the power of 10 to the power of 56 years, these random quantum fluctuations could recreate the conditions of the primordial universe by causing a Big Bang to emerge from nothingness, thus giving birth to a new universe. And this type of event in an eternally expanding universe could happen an infinite number of times. Maybe it has even already happened, and our universe comes from that. Some researchers actually think that the period of accelerated inflation we observe near the Big Bang could be the future, extremely distant from a previous ever-accelerating expanding universe, a universe so old and so vast that it would have produced us within it. Thus, it is theoretically possible that a perpetually expanding universe could eventually give birth to babies. Mutually inaccessible universes, some of which resemble the one we are in. Some will tell you that knowing the universe probably won't die in a dramatic apocalypse of heat and fire, but in silence and cold, through a slow, continuous slide into eternal sleep, without energy and perhaps without awakening, is pointless. For others, these distant futures, over which we have no control, are a source of paralyzing melancholy. For me, and hopefully for you too. Think about these events so far removed from us in time, and which go far beyond our own death and that of all our descendants. These are candies for the mind that allow us to appreciate how lucky we are to be privileged observers. We appeared in a period of our universe's history when it is still filled with stars and lights. A period in history during which, on one planet among many others, matter that was briefly organized produced living beings. Conscious, fragile, and able to ask themselves, for the sheer pleasure of curiosity, how will the cosmos die? In a sense, we are fragments of the universe contemplating itself, studying itself. Let's make the most of it while there are still things to see. The light won't last forever. The scenario we just explored is called the Big Freeze, and based on our current knowledge, this thermal decay that eventually plunges the universe into a prolonged coma is, at least for the first two parts of the video, the most likely scenario. Just for the fun of playing with the end of the world. In other upcoming videos, I'll take you to explore the competing possibilities for the end, which can't be completely ruled out today, and in which the cosmos ends in a radical way, by tearing itself apart or collapsing.